Hello, I am Pete Demar with Battery Research and Testing, and I will be narrating this session of our stationary battery maintenance tech tips. This is tech tip number 21, how to measure plate polarizations. In this tech tip, we're going to show you how to use a reference electrode to measure plate polarizations. This is so simple that even I can do it, as you will see. In order to get fairly accurate measurements, you will want to be sure to use a reference electrode that has the same density, think specific gravity, electrolyte in it, as the electrolyte in the cell that you are working with. You can use an electrode that is filled with a different strength electrolyte, but it will not be as accurate as if you had the same strengths in both. The plate polarizations show you exactly which each plate group is contributing to the voltage that is measured on that cell, plus how much overpotential polarization is being placed onto each plate group. By plate group, we mean the positive plates and the negative plates in the cell. All manufacturers typically want to have between 20 and 50 millivolts on the negatives and between 60 and 120 millivolts on the positives of overpotential on the respective plate groups. This is in order to keep the plates properly charged. Overpotential is that amount of voltage that is above what the open circuit voltage is for that particular cell design. Hello. In this video, we're going to show you how to measure plate potentials. We're just going to use a standard reference electrode. This is a 1210 gravity in there because that's what the cell is. This is a C&D 3 DCU9. I've already taken the vents out of it, but we're going to measure the overall potential. As you can see, it's 6.202. Cell number 1, I'm starting with a positive, is 2.067. Cell number 2 is 2.066. Cell number 3 is 2.068. Now I'm going to pull out my negative lead. That's what I'm going to plug the reference electrode into. Put that in cell number 1. And now I'm going to measure the plate potentials of these cells. From the electrolyte to the positive plate, it's a positive potential of 1.137. And to the negative, it's a negative 0.925 volts. Move the reference electrode to the next cell, and we measure to the positive 1.137, and to the negative, a negative 0.924. Move it one more time. To the positive, a positive 1.138, and a negative of 0.926. And these things easily can vary a thousandths or two, so that's not critical. This is just to get you real close. I'm not going to put the vents back in. I'm putting recombiners in. These are the recombiners that we like because they recombine the gas and basically eliminate having to add water to the cells. What we really like about this design is it's so much more compact than anything else that's on the market. You can see it, and that particular recombiner there will recombine the gases from, a 10 amp cell, if anybody makes that, up to a 2,000 amp cell under normal operating conditions. I am now going to hook up the leads for our temporary charger, and we will be charging this overnight. Let me plug this back in. And I have the charger set at Excuse me. Because this room is 52 degrees, that's what that cell is, and the normal float on this would be about 2.25. So to temperature compensate, I've actually turned the charger up to 2.30 volts. So that would be 6.96, so that's really about 2.30 volts per cell where I want it. We're going to let it charge overnight at that, and it's taking about 4.1 amps right now. This is the National Railway charger, the HF Max, that we're using for boost charging cells. This is a shop charger. You can mount it permanently, but we use it in the shop. And what we like about this one over the other ones we've been using for the last, 12, 15 years, is this is a lot lighter. That thing there will go up to 20 volts and put out like 40 amps. Each of those power supplies, they call them IPMs, Intelligent Power Module, in the bottom is good for 20 amps. If you want, you can just put one in there. They only weigh about 6 pounds each, so the whole thing's about 25 pounds. But we're using this with this setup. I didn't show the charger before, so I am now. It's real easy to work. We like those thumb screws. I mean, you can use anything, key fob or whatever, to adjust the volts per cell and how many cells you want. This is a continuation of the reference electrode video that we started yesterday with this the C&D 3DCU9. It was off charge. We recorded the cell voltages and the plate potentials yesterday. Today we put it on charge at 2.30 volts yesterday because the room temperature is like 53 here, so the cell will be at 53. I already took the vents out. We're going to measure the overall voltage in each individual cell voltage. Then we're going to do reference electrode readings again. The overall voltage is 6.96 volts. Cell number 1 is 2.273. Cell number 2 is 2.318. And cell number 3 is 2.382. I'm now going to unplug one lead to free it up for our reference electrode. Going to use the same reference electrode that we used yesterday. Put it in cell number 1. And the polarization of the positives is 1.303 or 1.302. To the negative is a negative 0.964 volts. Move the reference electrode to cell number 2. The positive is 1.299 and the negative is a negative 1.014. Move the reference electrode to cell number 3. The positive polarization is 1.304 and the negative is 1.073, 1.072. Whatever. Let them back and forth. I want to go back and check cell number 1. 1.304 positive. Negative 0.964, 965. Okay. It's going to be completion of this video on measuring plate potentials. I do need to clarify some of my statements made here. I frequently use the word polarization or potential improperly. The potential is the actual voltage that is being measured. Polarization is the difference between the open circuit potential, voltage, was and what the voltage is on charge. Sorry for the confusion. Hopefully, this tech tip has been a benefit to you by showing you how actually to measure plate polarizations and how easy it is to do it. If you are interested in learning more about what we do or how we might be able to help you, please go to www.batteryresearch.com and look around. If you would like to be notified when we release a new tech tip, please go to info@batteryresearch.com and tell us to notify you when we release a new one, or if you just have a question on a stationary battery subject, just do the same.